through question 6 as another example in case any of you need it. So this one's got a cylinder. It's expanding in such a way that h is always double the radius. So it might help you by drawing a picture. And then you should know that the volume of a cylinder is a third pi r squared times h. And so we're told here that the length h is always double the radius. Okay, so that means 2r is going to equal h. Okay, because h is always double r, so if we do 2 lots of r, that will equal what our h is. Now we need to find the rate of change of the volume with respect to r. So we want to find dv dr. Okay, so that's the first thing we need to do. We've got our volume and we've got it in terms of r, but we've also got it in terms of h. So we need to replace our h with what we've got over here. So the fact that h is 2 lots of our radius. So that means our volume, so if I do a down this side, that means our volume is going to be a third pi r squared and then times by 2r. So that's 2/3 of pi r cubed. Okay, so now we need to find dv dr. So now we're going to differentiate with respect to our r. So we're bringing the power down, so that's going to cancel with the third to leave us with 2. And then we've got our pi, which is just a constant, and then our power goes down by 1. So we've got the rate of change of the volume with respect to the radius is that. And they don't want it at any particular point, so there's nothing to substitute in, so we're done with that one. Now we want to find dv dh, so the volume change in volume with respect to our height. So for this one, we're going to do the same thing again, but we want our volume this time in terms of h. So 2r equals h, so that means h over 2 equals r. So we're going to end up with a third pi, and then instead of r squared, we're going to end up with h over 2 squared times by rh. So if we square h, we've got to square the 2 as well, so we end up with 4 times 3, or a quarter times a third, so we end up with 1/12 pi h cubed. And then we need to find the volume, so the rate of change of the volume with respect to our height. So we're differentiating this. So we bring down the power, so that cancels with the 12 to give us a quarter, and then we reduce the power by 1. And that is it. So it's all a case of bringing together everything that we need to do.